Lesson 5. Simplifying a cos x plus minus b sin x. You can use the addition formulae to simplify some trigonometric expressions. For positive values of a and b, a sin x plus or minus b cos x can be represented as r sine of x plus or minus alpha. For a cos x plus or minus b sin x, it can be expressed in the form r cos of x minus plus alpha, where r is bigger than 0, 0 is less than alpha, which is less than 90 degrees, or pi over 2 radians, and where r cos alpha is equal to a, and r sine alpha is equal to b, and r is equal to the square root of a squared plus b squared. You can use the addition formulae to expand the sine of x plus minus alpha, or cos of x minus plus alpha, and then equate coefficients. Let's do some examples. Show that you can express 3 sin x plus 4 cos x as a r sine of x plus alpha and b r cos of x minus beta, where r is bigger than 0, 0 is less than alpha or beta, which is less than 90 degrees, and r, alpha, and beta are given to 1 dp when needed. For part A, r sine of x plus alpha, when expanding the addition, we get r sine x cos alpha plus r cos x sine alpha, which is the same thing as 3 sin x plus 4 cos x. And so we see here we have a sin x and we have a sin x here. So r times cos alpha is equal to 3. And here we see we have a cos x, so r sine alpha is equal to 4. If we divide this by this, we get r sine alpha over r cos alpha is equal to 4/3. The r's cancel, and we get tan alpha is equal to 4/3. So alpha is the inverse tan of 4/3, which is about 53.1 degrees to 1 dp. If we square both of these and add them, we get r squared cos squared alpha plus r squared sine squared alpha is equal to 3 squared plus 4 squared, which is 25. Here we can factor out r squared, and we get cos squared alpha plus sine squared alpha is equal to 25. We know cos squared alpha plus sine squared alpha is just equal to 1. So r squared is equal to 25, and as r is bigger than 0, r is equal to 5. And so therefore, 3 sin x plus 4 cos x can be rewritten as 5 sine of x plus 53.1 degrees. For part B, r cos of x minus beta is the same thing as r cos x cos beta plus r sine x sine beta, which is equal to 3 sine x plus 4 cos x. Here we have a cos x and we have a cos x here. So r cos beta is equal to 4. And here we have a sine x and we have a sine x. So r sine beta is equal to 3. And again, dividing, we get r sine beta over r cos beta is equal to tan beta, which is 4/3. So beta is equal to 36.9 degrees to 1 dp. And then squaring the both and adding them again, we get r squared is equal to 4 squared plus 3 squared, which is 25 again. And so r is equal to 5. And so therefore, 3 sine x plus 4 cos x can be rewritten as 5 cos of x minus 36.9 degrees. Let's do another example. f of theta is equal to 12 cos theta plus 5 sin theta. Part A. Write f of theta in the form r cos of theta minus alpha. And then B. Find the maximum value of f of theta and give the smallest positive value of theta it occurs at. For part A, 12 cos theta plus 5 sin theta is going to be the same as r cos of theta minus alpha. And we expand this, we get r cos theta cos alpha plus r sin theta sin alpha. And so by equating coefficients, we get r cos alpha is equal to 12 and r sin alpha is equal to 5. We get r is the square root of 12 squared plus 5 squared, which is 13, and alpha and tan alpha is equal to 5 over 12, so alpha is equal to 22.5 degrees to 1 dp. And so therefore 12 cos theta plus 5 sin theta can be rewritten as 13 cos of theta minus 22.5 degrees. Sorry, I mistakenly said 22.5, I meant 22.6 degrees. For part B, the max value of f theta, or 13 cos of theta minus 22.6, the max value will just be 13. It will be the coefficient, when cos of whatever this is equal to 1. It happens when cos of theta minus 22.6 degrees is equal to 1. So theta minus 22.6 degrees is either minus 360 degrees, 360, 0, etc. The smallest value of theta will happen for not adding to minus 360 degrees or adding to 360, but when you add to 0. So theta is equal to 22.6 degrees. And that's about it.